So today I want to start chapter 11 about conic sections. There are three conic sections that we're going to discuss because we did circles before. So we're going to do parabolas, and please listen up because that's important. We're going to do parabolas in 11.1, ellipses in 11.2, hyperbolas in 11.3, and then 11.4 has parabolas, ellipses, and hyperbolas, which is centered at HK. So what I'm gonna do, I'm not gonna do 11.4 separately. Whatever is required from 11.4 for 11.1, I'm gonna embed it in 11.1 and then 11.2 and 11.3. I think it would be more efficient that way. So 11.1 has 11.1 and sum of 11.4. 11.2 have 11.2 and sum of 11.4, and so is 11.3. So we're gonna start by doing geometric definition of the parabola. We're gonna define parabolas totally different from what we did in math 1150. So what is a parabola? A parabola is defined in terms of two fixed entities, a fixed point and a fixed line. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Okay, so a parabola is the set of all points. You know, all this is written in the notes so you can read it. It's the set of all points that are at an equal distance. So point A would be on a parabola whose focus is F and whose directrix is D. If point A is at the same distance from F as it is from the directrix. So AP has to equal AF for A to be on the parabola. The collection of all these points that are at an equal distance, okay, any point you pick on the parabola has the same distance to F as to the directrix, and so on. So you can see in this case we get a parabola that opens sideways to the right. If the focus is on this side, then we're gonna get a parabola that opens to the left. If the directrix is horizontal and the focus above it, then you're gonna get a parabola that opens up. And if the directrix is horizontal and the focus is below it, then you're gonna get a parabola that opens down. The focus will always be inside the graph of the parabola. You can see inside. Okay. All right. So let's define all the properties of parabolas. Vertex. When they say vertex, what is the vertex? The vertex of a parabola. We all know what a vertex is from functions. Parabolas that are functions. This is the vertex. It's halfway between the focus and the directrix. So if this W, then VW has to equal VF. Okay, vertex is the midpoint between the focus and the directrix, always. The axis of the parabola is the line that's going through the vertex and the focus and perpendicular to the directrix. Remember the axis of symmetry? It's the line through the vertex, through the focus, perpendicular to the directrix. A parabola is symmetrical about its axis of symmetry. So let's look at the standard form of the equation of a parabola. Standard form of the equation of a parabola. It's x minus h squared equals 4p y minus k, where vertex as before is at hk. You can see that x is square, so it's either going to be it's x squared, so it's either going to open up or down. It has a vertical axis which means it has a horizontal directrix. It has a horizontal directrix, and the equation of the directrix is k minus p. K minus p, well, you don't really have to memorize this. I'll show you how to get it by memorizing. The parabola opens up if p is positive. P takes the place of a. Remember, we used to have a x minus h squared is y minus k. We used to have y equals a x minus h squared plus k. So if you move the k over and divide the a, so basically 1 over a is what we use for p. So a is positive, and so on. And parabola opens down if p is negative. Okay, now if vertex is at 0, 0, then you're going to see x minus 0 squared equals 4p y minus 0. So equation is x squared. So whenever you have vertex at 0, 0, that's going to be the equation, and vice versa. And so when you have x squared, it's going to open up or down. If it's y squared, y minus k squared equals 4p into x minus h, it's going to open. Same vertex as hk. It's going to open right or left, so it has a horizontal axis and a vertical directrix. It's all in the notes, that's why I'm writing them fast. And the directrix is x equals, and don't memorize this, I'll show you how to get it. You just opens to the right if p is positive, left p is negative, and if vertex is 0, 0, then it will be y squared equals 4px. Okay, in both cases, it's very important. The focus lies on the edge of the parabola, absolute value of p units from the vertex. So the focus for this one is going to be absolute, because p could be negative, so it's a distance. And the focus for this one would be absolute value p units from the same thing here. Focus. The distance between focus and vertex is absolute value of p. Okay. One other thing is important about parabolas. It will help us draw a quick parabola is the latus rectum and graphing parabolas. What is latus rectum? When we say latus rectum, let's say what that is. The latus rectum of a parabola is a line segment that passes through its focus, perpendicular to the axis of the parabola with endpoints at the parabola. The latus rectum of a parabola is a line segment. It's a line segment that passes through its focus. So say we have a parabola that opens up, and there's the focus. So it's going to pass through its focus, and it's perpendicular to the axis. There's the axis. And it ends at the parabola. Its length is called focal diameter of a parabola. Focal diameter of the parabola. So you measure this. This is the latus rectum. When you measure it, it's called focal diameter. the focal diameter is absolute value of 4p. Why is that? Because the distance between the focus and the vertex is absolute value of p, that's positive, so that's p, and then you go 2p on each side, because this is a parabola, so it's x squared equals 4py, right? It opens up, it's centered at 0 0, it's x squared. So if y is p, that's y. If y is p, then you get x squared equals 4p squared, so x equals or minus 2p. So x would be 2p on this side and negative 2p on that, a total distance of 4p. You can see why. Okay, so this is just an example. So the focal diameter is always the line segment, it's the length of the line segment that goes through the focus perpendicular to the axis of the parabola, and its length is absolute value of 4p. Okay, its length is absolute value of 4p, no matter which way the parabola is going. Okay, so let's look at some examples to clarify all this. Example 1, so we need to find focus, directrix, and focal diameter of the parabola and sketch its graph. X squared equals negative 20y. So obviously the vertex is at 0, there is no h or k, and it's x squared, so it's either going to open right up or down, but 4p is negative 20, so p is negative 5. It's going to open downward. And again, let me show you the easiest way to graph it without plotting points. So we start at the vertex, it's 0 0. P is negative 5, so the focus has to be 5 units below, right? Because it's the distance between the vertex and the focus is absolute value of P. And now this is what you do. This is P units, so you're gonna go 2p. Remember the focal diameter, its length is 4p. So if this is 5, then you're gonna go 10 units on each side. So you're gonna go 10 units on this side and then 10 units on that side. And you get a point here. So the focal diameter, this is the latus rectum, its length called focal diameter, it's 20 units. 4p is 20 units, absolute value, 20 units, 10 on each side. So this is a point, this is a point, this is a point. You connect them with a parabola and you get a perfect graph. And if you don't believe me, look, when p is negative 5, when y is negative 5, if you put a negative 5 for y, x squared is negative 20 times negative 5, x squared is 100, so x equals plus or minus 10. So you have 10, negative 5, negative 10, negative 5, 2 points on the graph of the parabola. Beautiful, isn't it? Now the directrix. Remember, the directrix, the vertex is halfway between the focus and the directrix. So the focus is 5 units below, so the directrix have to be 5 units above. And it's perpendicular to the axis of the parabola, so this is directrix. And its equation is y equals 5, right? 5 units. Here's another one. Example 2. Same questions, y squared equals negative 14x. So obviously the vertex is at 0 0, it's y squared, so it's going to open right or left, but 4p is negative 14, so p is negative 3.5, so it's going to open to the left. And let's see, so the vertex is at 0 0, p is negative 3.5, so we're going to go 1 2 3 4, so that's negative 3.5, so that's p right there. So we're gonna go 7 units above and 7 units below to get the points. That's 7 to get the latus rectum, and the length is the focal diameter. So we have negative 3.5, negative 7, and the 3.57. You connect them, and the latus rectum is 14. I mean, the focal diameter is 14. And the direct is going to have to be 3.5 units on this side. It's a vertical line. This is the axis. It's always perpendicular to the axis of symmetry. So this is x equals 3.5, which is the directrix. And again, if x is negative 3.5, if x is negative 3.5, then y squared is negative 3.5 times 17 is 49, so y equals plus or minus 7. So you can see, you can always get it if you don't want to. Now there's one for you to work on page 5, so work it out. X squared equals negative 84, okay? Now I'm going to pick example 3, which is from 11.4. Remember I told you I was going to embed 11.4 in 11.1, 11.2, and 11.3. So this is from 11.4. The center meaning is not at 0, 0, or the vertex is not at 0, 0, which obviously is not. So you can see that the vertex, the x value is 5, the y value is negative 2. It's x squared, so it's going to open up or down. 4p is 12, p is 3, so it's going to open up. Let's see. The vertex is at 5, negative 2. 1, 2, 3, 4, 5. 1, 2. This is the vertex at 5, negative 2. P is 3. So the vertex is here, it's going to go up. So P is 3. So we have to go, that's P, that's the focus. Remember, the focus is P units away from V inside the parabola. So we're going to go, that's 3. So we're going to go 6 units to the right. 2, 3, 4, 5, 6. So this is at 5, and then you add 6, so it's at 11, and then 6 units to the left. 1, 2, 3, 4, 5, 6. You're at negative 1, so there's another point at negative 1, 1, and this is 11, 1. And you can, that's the focal diameter, and this is the parabola. So the focal diameter is 12 units, and the directrix. So the directrix, the axis of the parabola is right here. It's the line through the focus and the vertex. Its equation is x equals 5. So the directrix is going to be 5 units. So the focus is 5 units on this side. The directrix is going to be 5 units on that side. So we're at negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. This is 5 units. So this is the directrix. Its equation is y equals negative 7. No, wait, that's how many units? That's not 5. That's 1, 2, 3. Sorry, that's 3. So we're gonna go 3 units. My bad. 1, 2, 3. So we're at 3 and 2, so it's negative 5. I made a mistake. Okay, please go ahead. It's negative 5. Okay, another example from 11.4. Section 11.4. Y plus 5 squared equals negative 6x plus 12. So we write it in standard form. Pull the negative 6 out. It's y squared, so it's going to open right or left. But 4p is negative 6. P is negative 1.5, so it's going to open to the left. Again, let's do the same stuff. The vertex is at x equals 2, y is negative 5, 1 2 1 2 3 4 5. So this is the vertex at 2 negative 5. It's gonna open to the left, so the focus is gonna be p units inside, so that's 1.5 1 1. So there's the focus. It's at 0.5 negative 5, 0.5 negative 5, and then that's 1.5. So we're gonna go up 3 and down 3 to get the latus rectum. 1 2 3 2 3. So this is at negative 5, 4 negative 3. This is negative 2, negative 6, negative 7, negative 8. And this point is at 0.5 negative 8. This point is at 0.5 negative 2. And go this way and that way. There's the focus, there's the axis of the parabola at y equal negative 5. So the directrix will be 1.5 point on this side. So you're at 2. So you go to 3, 3.5. This is the directrix. X equals 3.5. Okay, very interesting. Now if it's not in standard form, so let's see what we do. Okay, so here's again from 11.4, section 11.4, write equation in standard form. And graph the parabola. Y squared minus 2x plus minus 2y plus 8x plus 9 equals 0. So we're going to do completing the square on the y's, and then that means the x's have to go to the other side. So we divide the 2 by 2, we get 1, we square it with 1, so we're going to add 1 to this side. And that's y minus 1 squared equals negative 8x minus 8, which is negative 8x plus 1. So this is in standard form. The vertex is at negative 1x, 1 for y. And it's going to open sideways because y is squared. 4p is negative 8. So it's going to open to the left. So let's see. It's going to open to the left at the vertex, which is at negative 1 1. The vertex is at negative 1 1. This is the V. And P is negative 2. P is negative 2, so we're going to go 2 units to the left to get the focus. So the focus is at negative 3 1. And we need to go up 2p, down 2p to get the focal diameter. So p is an absolute value is 2. So we're going to go 2 up, 4 up, 1. So we're at 1. So we're going to go to 2, 3, 4, 5. So we're going to go 4 units up. And then 4 units down. From there, so 1, 2, 3, 4. So we're at negative 3. So these are the 2 points, negative 3, 5, and then negative 3, negative 3. These are 2 points on the graph. Connect them to the vertex. And we are in business. This is the axis, which is going to go through the focus, the vertex. And it's horizontal in this case, so y equals 1. The directrix, this is 2 units, so we're going to go 2 from the vertex, so 1, 2. So there's the directrix, it's x equals 1. And we got everything we need. Focal diameter obviously is 8 units, right? 4 on each side. Here's another one. Example 5, or whatever number it is, I don't know, 5. The equation of a parabola if its focus is -3, 0, and directrix x equals 3. Okay. So if you just do a sketch to get what kind of equation you're looking for. The focus is at -3, 0, and the directrix is at x equals 3. So the directrix is at x equals 3, and the focus is at -3, 0. Remember, the x is halfway between the directrix and the focus, so it must be at the origin, and the parabola has to open sideways to the left, right? It has to enclose the focus. So right away, if it's 0 and it's opening to the left, so it's y squared equals 4px. There's no h and no k, there's 0, and p, as you can see, has to be negative. It's -3, so y squared equals 4 times -3 is -12x. Here's another one from 11.4. Example, section 11.4. Find the equation of a parabola with vertex -3, -4, and focus -3, -1. So let me again plot these 2 points. Okay, so I'm sorry, it froze for some reason. It's internet. Find the equation of a parabola with vertex at -3, -4, and focus at -3, -1. So if you plot these 2 points, we get an idea what we're looking for. So the vertex is at -3, -4. There's the vertex. And the focus is at -3, -1. So obviously the parabola is going to open up. Its hk is not 0, 0. It's -3, -4. It opens up. So it's x squared. So we have x minus h squared is 4p y minus k. So h is -3. So we put plus, and then y minus -4 is y plus 4. All we have to do is find p, but remember p is the distance from the focus to the vertex, and it's positive because that opens up. So from -1 to -4 there's 3 units, so p is 3, so that's 12 plus 4, and that's x plus 3 squared. P is 3. Okay, one example. 62, page 790. Page 790. Let's see, it's an application. Page 790, number 62. Okay, here we go. It says a reflector for a satellite dish is parabolic in cross-section with the receiver at the focus. The reflector is 1 foot deep and 20 feet wide from rim to rim. How far is the receiver from the vertex of the parabolic reflector? So what I did, I graphed that. They have a graph in there. So the receiver is at the focus is the receiver, and this is the we know there's 20 feet, so it's 1 foot deep, 20 feet across. So this is 20 feet, 10 feet here according to the picture, and 10 feet, and that's 1 foot. And so this is the vertex, obviously. So if the vertex is at 0, 0, then, and it's opening up, so it's x squared equals 4py. Remember, p is the distance from the vertex to to the focus. So when x is 10, y is 1, right? When the picture x is 10, y is 1. So 10 squared equals 4p times 1. So 4p is 100. So p is 25. So that distance is 25. So the receiver is 25 feet above the vertex of the parabolic reflector. Receiver is 25 feet above the vertex of the reflector. That answers the question. And that ends section 11.1. Until 11.2, have a good night. See you tomorrow, actually.